All right, we're recording. Yippee. Um, so yeah, I just want to take some time to go over how to set up your computer, be able to 3D print, and just a couple of general tips. I did the same thing last semester. Um, but yeah, we'll get into it. How many of you or have Cura or some sort of slicer on your laptop already?
Bamboo.
You just can't use you just can't use that for Creality machines. So I guess we'll start with that. If you can download Cura, I'll show you how. It's easy. It takes a minute unless you have this computer, which has been taking a while. Cool. So, and my screen isn't sharing. Let me do that real quick before I forgot. Okay, I'm sharing screen. I Googled Google, or I Binged Google. All right, I'm gonna Bing Cura. That's Cura. Fun blue logo made by Ultimaker. So you should hopefully be able to find it if you do that. Right off the bat, they hit you with apart from the cookies, they hit you with just a big download button. So you can do that for, you know, Windows, you'll click the exe. For Mac, depending on which, one you have, click that. Um, but I want to wait for a couple minutes to make sure everyone gets this installed real quick, because that way we can run through some things. Do you have a Bamboo printer?
Yeah,
Which one?
he wants. I mean, I could have upgraded to the carbon, but
What, the X1?
yeah, the X one.
But there's not a whole lot.
Yeah, there's not a
to
whole
do
lot.
with if you want to. There's a few more materials, but not that. You can upgrade the nozzle and the podcast to, doesn't get as hot, but it can do. It doesn't have an AI capability to check your adhesion for example. I really don't. That's my favorite fuck something up on the P1 that's from my own hair.
What?
Not
You have any
like,
plans for
really,
this?
it's never.
My
been-
birthday is this Saturday.
Oh, really?
Yeah, my friends and I are going to
Printing out
Chicago.
screens and stuff.
Saturday.
That's the most silliest thing I picked that was just to update it. Like that happens sometimes. I was
I might come back early, I don't know.
I was at a standstill for a while.
Cause
I was
Brian's
wondering
gonna be
what was
here.
going on.
Luke's gonna be
And it was just an
here.
update.
All weekends.
Yeah,
Stuff like that.
it was,
Well, Luke doesn't get a fall break because he's in here.
Oh, yeah, that's
so it surprised me.
They don't have
It doesn't
fall
a
breaks
rubber
there.
extruder.
Well, he's also
So,
only
filling
taking
goes right
8
into the head,
courses.
and it comes
So
out.
he's like gonna have a whole half
So,
a semester off.
Yeah, but he wants
Since
to-
they're over,
yeah,
like,
I'm used to on my ender, when you run out of filament. It knows beyond the filament sensor, there's some filament.
He gave me
but
the
there
code to
might
your
not
house.
be-
I know,
there's no
well, he
like,
told me.
above it, I guess, right? So for the Ender 3,
Well,
you have
our
the
roommate didn't
sensor
even know
weight
the code
goes
until I
slow,
told him.
and you have that
That's
string of
fine.
filament that's still there, you have to eject it, then you put new filament in.
Yeah.
Oh,
But
that's
the P1X knows to use literally all the filament. So it's like,
Yeah, we can have
okay, you ran
that.
out of it, and I know that there's this much
Perfect.
left. I didn't know the sensor was
We
right above
can't
each
do out
other.
outside.
So it knows there's like an inch or
We can
two
do out
left, and it
inside,
just
not
uses it.
outside.
That's
But-
amazing.
We can go out, we can go out.
So,
We can play pong.
I would end up
Yeah.
on the frame to finish
Okay.
it,
Because our neighbors
fix the
are
filament.
What if
I
someone gets
ejected
switched
it,
up?
nothing
We need
came out, and I'm like,
to rematch.
well, now it's stuck. I didn't
Fair,
realize
that's fair.
it used
That's a
all of it,
valid
to
excuse.
eject,
Yeah.
like that. It took me a month and a half to figure it out. It was very nice.
I think the reason they got called is because we were wrestling in the backyard.
You were wrestling, that's why.
That's probably what it was.
It's so weird. I've never had a printer like this.
I love it.
So
It's so bougie.
I had a printer, my first enclosed printer, my first printer was that. I got it 7 years ago now. I got it for Christmas in freshman year of high school. It was great until it wasn't, and it was a disaster.
Yeah.
But the Bamboo Lab, the support is amazing. They offer a ton of replacement parts just on their website. The quality is insane. The heated enclosure is great. The monitoring is really nice. You can just upload it without having to do any like port forwarding setup on your network, which is awesome for my apartment because my network isn't managed by me. So, it's
We got
just
one
so
at work
great.
like over the summer and it was so.
You can also convert your G code in with a slicer to have like, I don't know if you've made one of those tools yet that removes a print from the bed. But you can make this like bumper almost that goes in front of the extruder.
Oh, I haven't done it.
You can add this G code template that people have developed online already that
Mhm.
lowers the extruder in front or like lowers it behind the print, comes down and just like scrapes it off like a bowling alley
That's
does.
so cool.
Oh, it's
Clears
like
the
mass
print.
production for
Yeah,
like little
clears the
toys and
print.
stuff like that.
Then you can throw another line that reloads the file and starts it again. It's so convenient.
Yeah, so like they have like a
Right.
bucket prepared already.
Yeah, they'll leave the door open, they'll have a stepper motor to open the door and dump the part out. And it'll just, because, so normally there's
Yeah.
two types of printers, there's PEI, like spring steel, which is just like sheet of steel and it prints onto it, and then there's
Yeah.
glass. Which is a bed of usually glass with these small like thermo beads, I don't know what you call them officially. And what happens is as they warm, they adhere to things really well, and then when they cool down from the bed, no longer heated, they shrink.
Yeah,
So the part that's adhered to it, it's like ungluing itself from it, you can just lift it off the bed, you don't have to scrape it, you can't.
Or you
scrape
could
it.
just crack it around.
The glass beds you can't break though, you can't bend.
I hate my glass bed. I was like, oh, glass is so nice. It sucks. It's so like, yeah, in frames are just so hard.
Yeah, if you print something small, that's just not going to. But if you're printing something tall, it's so convenient because the adhesion is amazing, but until it's not.
I got this like giant cut in my hand because somebody sharpened a scraper that we like you put for your printer, so it was a glass bed. I had my hand in the wrong
Yeah.
Oh,
spot.
no.
I've done that, I've jagged something toward me, it's gone away from my hand.
Yeah.
But the bamboo printers are PEI spring steel
Mhm.
with those beads on them.
And
So
they're
it's
all
like,
textured.
so it's
yeah.
textured with that and it's incredible. Oh my God, it's awesome. I never had heating issues. I'm used to having like the Ender 3, even if I put like a little like bin around it,
Mhm.
running a rack or something. Cool. Are you there? Yes, hang, I'll get there. Just making sure you got it.
Oh, I got it.
You got it?
Yeah.
You got it?
I'm on the welcome the setup.
Yeah, and do the install real quick.
I just accept everything and install.
Yeah, let it take over your computer.
I got you.
Bamboo is so, it is, and they give you a ton of presets, which are actually really accurate to what they represent, like. The layer height goes down to like what, 0.08 millimeters or something like that, it goes down to something stupid thin, like literally thinner than paper.
Jeez.
It's insane. Of course, the print time is jacked up, if you want something like high quality, you can print with that, and it's like, you really can't tell, it looks like it was injection molded, it's insane. So.
I convinced me to buy my one wheel and it was like the best purchase, so I think I'm letting you convince me.
It really is a good printer, like they,
It
so
really
they ran the sale over the summer, it took like $150 off of it, and it was so worth it. Like, I would pay $150 more to get another one,
Mhm.
but I have that one, an Ender 3 and a resin printer right now in my
Oh,
apartment, and my roommate has his own line. My roommate likes the cheaper ones just because so he can, you know, prototype with a bunch of stuff and have them running all the time,
Mhm.
like that's his use, but I'm like, yes, but the tolerances on the Bamboo Lab are incredible. They have all their thermo expansion calculations done for their materials. So
Oh.
you're like, I want this part to be 2 inches long, you measure it with calipers, it's like 2.007 inches, there's perfect. It's within like 2 thousandths of an inch, it's insane. The parts fit amazingly. So,
I've done that for appearance holes when I'm doing
Yeah.
heat sinks.
Yeah.
For like the screw holes.
yeah,
It's pretty good.
anytime you want something to like slide, it's like a transition fit, like in between like a C channel sort of shape.
Mhm.
When you need to like either sand part or the finish, you don't have to do that. With the Bamboo Lab. It's like, it's insane. So. Yeah. But, all right, are you guys good? You installed?
Yeah.
Okay.
You can go ahead.
I will. Okay, here I am. I will now open Cura by searching for it, and it's not in my computer somehow. Okay. Really? That's actually kind of brutal that I have to now search for it. Not gonna lie.
You click open file location.
That's the installer.
Oh,
So I guess what I could do is open the installer and see where it wants to put it. C drive, was I not there? But I keep hitting the middle mouse button. Oh, that's awesome. That's just so cool. Okay, there it is. All right, hopefully, once you've installed it, you can open it without having to do that. I don't know why I had to do all that fun stuff, but okay. Okay. Wow, that's really annoying. Can I get rid of this, please? Oh, you're kidding me. Can I make this smaller? Hide video? Thank God. Go away, please. Okay. Um, I'm gonna skip doing this. You can do it. All it does is if I make, for example, a preset on this computer, I can sign in with my same account on another device, and those presets I've made are there again. So it's useful for like if you're operating between a school computer, like you probably will for setup here, and then also your own computer at home or whatever. Let me know once y'all get to this screen here. Chilling? I'll wait for Ton. It's okay. Good? Cool. All right. Right click on non-Ultimaker printer. Important note that we have a Creality Ender 3, V3 KE, and 3 Creality Ender 3s without that stuff at the end of it. They're both made by the company Creality. So we're going to set up a non one. It's not a networked printer. A networked printer is one that connects either to Wi-Fi or to Ethernet. So we're going to do non-networked. You can search by the brand here with this little thing. So it was originally dropped down to be Ultimaker. I'm just going to close that and sort of scroll until I get Creality, which apparently is Creality 3D. There's a lot, as you can see. They do now have a preset for this, which is convenient because the last semester when I ran this, they did not have a preset. So we'll set up 2 total printers. I'm going to run the nicer one first because this one's more trustworthy with prints. It's going to be the Creality Ender 3 V3 KE right here, which for my sake, I'm going to call ASME Creality 3. This literally does not matter, this name. Let me know once y'all are here. Chilling? I can't see you. I'm just going to assume that by you not making noise, you're good. Okay. Don't touch these things. Machines run off of what's called G code. These are essentially protocols that the machine understands based off of the motors, sensors, and abilities it has. So do not do this. For example, anything beyond the semicolon is a comment. So G28 is the protocol to home the stepper motors. M220, S100, M221, S100 are for the extruder stepper, sorry. And at the end of any print, it's gonna home again, do all that stuff, turn off the motors. Don't touch this. This is just for description. These you could hypothetically do on your own if you were to build your own 3D printer, which actually a lot of people do. This is just your build area right here. Elliptic is if you have what do they call those things? Like a 3-tower printer thing. It looks weird. I don't know. I have one. I can't remember what it's called, but it's prints horribly. The origin is not at the center. Again, this is all just preset that this guy made. Extruder settings, whatever, blah, blah, blah. You just hit next. Don't do anything with it. No one cares about what's new. Bye-bye. Okay, here's what you have. So, just to hit y'all with some controls, if you are using a trackpad, that works. You can usually do like panning and scrolling, panning and zooming with 2 fingers. For a mouse, middle mouse is going to pan. Right mouse click and hold is going, I'm sorry, right mouse is going to move. Middle mouse is going to move, right mouse is going to pan. In any case, here's what your setup looks like every time you open this application. I'll run through some of the stuff at the top these are the important things that you want to pay attention to whenever you start it. In this case, this is the printer name that we just added. If you have a second one, then it'll show up as another one on this list. So make sure you have the right one set up for what you plan on printing because it will mess up the printer if you put the wrong G code in the wrong printer. The plastic we're going to use is right here. Does not matter what this color shows up as. Don't know why it's yellow. We don't know why it's numbered 1. It also doesn't really matter what you pick for this. You can sort of get a preset off of it. And In other words, there's a lot of settings that you'll see in this drop down over to the right that can sort of be predetermined if you pick a preset from this application, but 9 times out of 10, you'll want to fine tune this yourself or Google settings for it with the filament that you buy if it's like somewhat experimental. So this does not matter. The only thing that I will point out here though is we're using a 0.4 millimeter nozzle, which means the diameter of the nozzle is 0.4. Some nozzles go down to 0.2, some go up to a millimeter or two for printing really fast things that don't have any quality whatsoever. These are just little alignment tools, isometric view, front, top, left side, right side. Again, you can do your own panning, but if you just want that, that's that. Preview is going to be for after you've sliced it. So you have a part file that's solid, doesn't have any lines in it or anything, but once you've 3D printerized it, it's going to have layer lines because the plastic is deposited in layers as a big line. This will show you what that view looks like. Since I don't have anything right now, it won't show me anything, which is fine. And then monitor is if you have something that the printer hooks up to the network that gives you settings or gives you a camera feed or anything that's here. We do not have that, so don't worry about it. Really only use prepare and preview. So back to prepare. If you want to add a part, it's going to be this cool looking folder here. In my case, I downloaded a little demo part that I'm going to chat about a little bit. So that's there. We see some settings on the left here once I have this part in. So my left mouse button now does something, which is normally moving with the move tool over here. So I'll just leave it back to where it was. Actually, I'm just going to zero this off. You can lock it in case you have a bed of a bunch of things and you're trying to move something particular and you don't want to be able to click and drag this one, but maybe you have something that's like right here in this corner you want to move. And these are just convenience things. Don't know what this is. Probably has something to do with something though. Scaling is
like makes it not float.
Interesting. These are scaling. So if you want to make it bigger, you can see the scale factor on the right or the actual dimensions in a cubic sense on the left. So these represent how wide it is, like in a 3D space or like a cubic space. So if you have a triangle that's like, how do I put this? If you have a circle, it's still going to draw a cube around it to figure out how big that volume is in XYZ sense. There's that. Uniform scaling is for that. You can also uncheck it and make it wide if you want. No one really does that though. Unless you're weird. Ow, I really messed it up now. Ooh. Okay. Yeah, whatever. Sure, cool. You can rotate it with these, blah, blah, blah. I want to undo that so I don't mess things up. You can mirror it, I guess. These are for support stuff, kind of weird. You can have a model either identify as a model or as a support to something, which is kind of weird, but you could model your own supports like in CAD in an assembly and export them separately. You can do a whole bunch of different things, blah, blah, blah. You can also paint supports or put support blockers, which means if you have a part you want to have a smooth finish or you don't want to have a support in a small crevice, you can put a blocker on it somewhere to have it not do that. This is kind of specific. We won't be doing that for most of the things we do. 9 times out of 10, if you have to put a support blocker in, there's another setting you can enable that you won't need to do anything with that, or your design is poor to begin with. But in any case, that was mostly useless. The stuff that matters is going to be in this drop down on the right. One sort of weird thing about Cura that is user-friendly at first, but after a while gets annoying is these are not all of the settings here with resolution, strength, support, adhesion. This is just some of them. So you can do show custom, and underneath every one of these drop downs, you'll see maybe one, but you can also hit the little settings icon and add all of these, which is a lot, but depending on what you're doing, it matters a lot. We'll go through the basic ones for now because I don't think many people are going to need anything beyond this. In general, the presets are cool, and I'll show you how some of this stuff, what it means. I'm just going to expand everything to begin with. So these values are all set under a profile, which is currently called standard quality. The little number over here to the right shows your layer height, which is this right here. In other words, how tall the plastic is going to be for each increase increment in Z. So super quality is going to be less than this, which means a finer print detail. If you're doing something like prototyping a part that you want pulled out pretty quick, you can do this. You can even make it higher than this. You don't really go higher than, for this case, since it's a 0.4 millimeter nozzle, if you did 0.5, it would just kind of float there and drop those filament weird. Don't mess with that, in my opinion. Just use these. Or you can also hit manage profiles and import something that you find online. It is a .cura profile thing. So if you Google good PLA 3D printing Cura, it's not printer dependent. You can just import that profile. I do that a lot. I don't use this materials tab here. I'll just import a profile called PETG because all this material thing is doing is changing the speed that it's printing and the temperature it's printing at. Any case. So when you open it, again, your view is this. You'll want to fiddle with these by the part. In this case, layer height of 0.2 is pretty nominal. If you want it to be really, really thin, you could do like, the small one 0.12 or try to do 0.08. There's a resolution to the steppers. So for every, step of a stepper, you have a change in angle of a lead screw, and the lead screw is threaded to a certain pitch, which changes the height of the extruder or bed relative to the opposite of it. So if you have a stepper with, I think it's 180 steps as usual or something like that. But your lead screw has like a pitch of like 4 threads per inch. It's going to have a pretty big jut for every little turn compared to like a lead screw with a 28 threads per inch thing. It's a lot of words. My point is this printer will not be able to go much below 0.12. It's just not designed to. Other printers that are of higher quality can. It's also heavily dependent on how sturdy they are with their frame. But in any case, these are really good things to just use. Again, you can see when I check this one, this layer height changes between those profiles. It seems that's actually the only thing right there. But if I do low quality, you can pay attention to the top and bottom right here. Those numbers do change. So I'll go through what some of these mean. When you 3D print, it's not solid. It has what's called infill, which means instead of giving it, like shelling out a part in CAD, you're making it hollow with some pattern on the inside that makes it have structural integrity. So your shell thickness is the top, bottom, and sides. In terms of this, your top thickness is right here. They made this number be these two. I don't know. In terms of layers, you can see it's 4. So this is actually going to be calculated. Your layer height is 0.2. You want 4 layers. It's going to make it 0.8. Hopefully that's simple math. Again, these really don't matter that much. I would only fidget with these values if you plan on heavily sanding the part and taking away material, in which case you want a lot more layers in the top, bottom, and sides because you're sanding away plastic. And if you sand too much, you'll get into the hollow region. Infill is going to be that pattern that I was talking about. The infill density is going to be mostly contributing to how flexible and then eventually fragile the part is. So if you're just, squeezing a little thing, you'll notice it with infill, but if you're loading the part, you want a higher infill. For example, I am currently suspending my hamster by my wall right now with wall brackets. Like his pen is with 3D printed wall brackets, carbon fiber reinforced. I want those at 100% infill because I like my hamster. If I put it at 1% infill and stick him on there when he goes to run on his wheel tonight at 5 a.m., I'll hear a crash. So higher infill, generally higher strength. You get into some weird variables when you actually put in 100% infill because it's still like drawing the pattern, but just like solid. It doesn't really just do like line by line solid. So weird tip, but this is just my opinion. Do 99% infill is the highest. I don't know. It just kind of messes up the print sometimes. Blah, blah, blah. Anyway. So yeah, that's infill. The pattern is right here. These all mean different things. I'll show you what they do mean. Again, right now, this is the part. If I slice it, I can see what that like 3D printerized model looks like in preview. In this case, this is going to be your top layer finish right here on the bottom. I don't really know why they add it, but they do. This is your layer like view. So if I bring it down to about halfway, I can see that infill pattern in there, which looks really, which looks really weird. It's not solid, obviously, but it's just to provide some strength. Wow, that's really zoomed in there. Okay, sure. So that's just to showcase there are different things. I prefer gyroid and cubic subdivision. Cubic subdivision, go away, please. Almost looks, go away. Almost looks triangular in here. Draws like a star sort of shape thing. Gyroid tries to pretty much mimic that, but with a weavy thing. So the current print time, I think after I did that last one was like an hour and a half. This one is 2 hours and 11 minutes. The infill pattern contributes greatly to the time spent. If you're doing any sort of circular pattern, it takes longer than if you're doing a straight line pattern, just in general. So there's that. But I would do cubic subdivision 90% of the time. I'll also show you real quick. The red is your outside. The green is going to be your inside wall here. In this case, it looks like the thickness is only 2 layers. So if I play with this value over here, which I'm actually going to do, that's your wall. I'm sorry. I think I blew past that. Top and bottom is top and bottom. Wall is the sides. That's 2, which is we see right there. If I make this number 5 and reslice it, it's going to be a lot wider. The part itself doesn't get bigger, but the infill now sits farther into the part. Provides more rigidity. Strength-wise, not a ton of difference. It's mostly going to be based off of infill percent. Just a couple little variables I want to toss out. But generally, play with the standard quality thing. Play with the other presets. They're fine. Material temperature will matter. You'll have to change this fairly frequently. This basically contributes to the viscosity of the material. PLA actually melts at around I want to say 160, 170, but it moves really slowly and it's hard to push through like a nozzle to have a smaller amount come out. If you put this at 300, PLA would obviously still be a liquid because it's only hotter, but it would flow like water through the nozzle. So if you print too, hot, the plastic will actually drool over the part, or the extruder will actually just generate too much heat and melt whatever's under it too. 200 is a general basic for it. Some people do 190, some people do 220. It also depends on how fast you're printing. So if you're printing really slow, if you're printing really cold but really fast, you're not going to push out enough material that you need. If you're printing really hot and really slow, again, you're going to get that melting thing. You will have to play with this number. You'll kind of just see if there's very obvious layer lines in a fine detailed print, it's usually because your temperature is wrong. If there's layer lines, it's usually too slow. If it's, kind of wavy or jaggedy, it's because you're too hot. Build plate temperature, I like as 60. You can do anywhere between 40 and 60. It's just to make it, you don't want the plastic has what's called thermal expansion. So when it cools down, it actually shrinks slightly. So if you put a layer on the bottom of the bed and it's not hot, it'll be depositing a hot material on a cold material and it'll shrink almost immediately and not adhere to the bed at all. So this is just a convenience thing. It gives you better adhesion. But some beds don't have heating and people use glue. Sounds wild, but that's what people do. Print speed, this defaulted at 300 because this printer can do 300. I like 300. In general, this is very silly to only have this setting shown because speed has all of these options right here. There's also acceleration to consider. There's speed when doing infill versus when doing top and bottom versus when doing walls. In terms of your outside finish, if you want it to be nice, you'll usually have it slower and the infill will just be fast. You can play around with that all you want. If this number gives you errors though, like either knocks your part off the bed or something is, bad detail, I would honestly just rip it straight down to 150 and work up from there. The max speed of the other printers, the other Ender 3s we have is 150. So this will literally cook them. 300 is fast. I never print above 300. I think our printers can go higher than 300, the bamboo ones, but I don't know. It's fast. You don't need it to be that. Blah, blah, blah. Retraction means when going between two towers like this printed on the bed, it will bring the filament up in the extruder before traveling so it doesn't drool a line accidentally over it. Doesn't really matter that much because you can usually just pick these little pieces of plastic off, but that's what also contributes to the hairiness of a part if you've ever seen that. You can enable it. You can also enable a setting that controls how much it changes by just figuring out which one of these it does. Z-Hop basically not only brings up the plastic from the middle like that, but it also brings the extruder up, so it's like super out of the way. Nice if you're printing fast because it usually makes a rougher surface finish and you'll hear like grinding. I don't know. This is fine. I wouldn't mess with these. Cooling good, don't mess with this. We're gonna talk a good bit about support in a sec, but I want to come back to it. And the adhesion, there's really only 3 types. A skirt is like a little line drawn around it, which is not actually adhesion. It's just sort of a goofy thing to see how your adhesion is before the part starts. It draws 3 little lines around it. If these start peeling off the bed, you can usually stop the print before it starts peeling this part off the bed. It's just a convenience for you to watch for the first 30 seconds and see how the plastic is doing. Next is going to be a brim, which basically builds a little pyramid-y sort of shape. It ramps up plastic into the part to make it wider than it is normally. So you can see from this view, it will put this little layer of plastic right here that ramps up to the part. Small, but it does slope up to it. Really annoying to peel off. You usually have to use snips, and it's a little too thick to do with your fingernail. This is for if you're printing something super duper thin and stupid, then use a brim. Otherwise, it's just going to be really annoying to get off the bed. The other thing you can do is use a raft. I'm not going to lie, the brim is annoying enough where I would just rather use a raft, which, yeah, uses more plastic, but marginally. So raft will put an entire layer or a couple layers under the part. So it just moves the part up, basically draws a big thing, lets it cool down completely, and then your print goes on that. So it peels off super nicely. It's not bonded to the part as much as like the layer adhesion within the part is. You can just peel it right off. I love them. It gives you a super smooth bottom finish. Again, this is using extra plastic and using more time, so only use this if you have a thin part that won't stick super well. But I like this over a brim any day. That's just me. For support, this is going to be needed to change every time you open this application. If you're printing a part like this, we'll look for what's called overhang, which is where some part has a shadow below it. It's cool because Creality gives you this little shadow down here. Now, you'll typically need support for, in this case, they say 45-degree angle, which this edge is chamfered most likely at 45 degrees. So I actually think it will do it if I have that. Yep. But if I made this, yeah. If I change this angle to be, I think 30 degrees would be, I think it's off the axis that it's printing on. So in this case, if I made it 44, might be red because it's bad. Yeah, so maybe 46. I think the red is trying to show me what is affected by the support. Yep. If I made it 46 degrees, and since it's only 45, it's not going to support it. I don't really know. It just did that for funsies. Ignore that. Maybe there's some micro part in there that's at an angle. But in any case, oh, we added more things. Okay, there. Yeah, you'll want to touch this every time. If you have any overhang indicated by the shadow, support's usually cool. If you're printing a really big part, like, is everyone familiar with the St. Louis Arch? Because of the, you just kind of look at the, like, it's a stupid way of saying it, but the derivative between like each layer, if you suddenly jut over like this compared to your layer only being over here before, it's going to fall. But the arch has literally an archway, so it's sloping over really slowly. By the time it's right here, you can do what's called bridging, where if the gap is small enough between two contact points, The plastic will sort of fall in for like the first layer, but afterwards it will draw a solid line on top of it and have a fine finish. But if you just have two posts that are 2 inches apart and you just draw a line between it, 90% of the time it's going to sag. So support's kind of convenient for that. This is cool to have at 30 degrees in my opinion. Now, this slope over is, nice, but it will be a cleaner finish with supports. So I like that. Don't really know what this one means, not gonna lie. I don't mess around with this. Everywhere or touching build plate determines if you have a slope here, but another slope that's somewhere above the part, like these right here, this archway. Will it put support with a base on the part? It will mess up your surface finish if you have supports coming off the part. So if you do everywhere, it's going to do that and it's going to be rough. But if you did only touching build plate, it's not going to support that area right there with the way we've done it. See? Now, the second version of supports is, go away, a tree support. Tree supports, instead of being a line that's drawn straight off the ground to support the part, can actually have an angle to them that looks like a tree or an organic support, some slicers will call it. So for this case, we actually can support this with a tree. It's going to draw a little shape off the ground over here that comes up and then goes, spits right over into it. We can see if I slice it. Like that. I can just tell that it's going to do that because I've done this before. So see, the bottom of the support is not touching the part that we're printing, so it won't mess up that finish. And it's still able to have like a weird angle thing that does this. You can also look into how much filament this uses. I like to let my prints be determined sort of by that. If I need something supported, I'll do that, or I'll paint on supports as you can do with some slicers. Like I think you can with this one. But otherwise, normal usually uses less filament. So in this case, I'm using 31 grams. Looking over here, it says, you point it with the mouse, but the support is 6% of the time doesn't show the material estimation. Of course it doesn't. If I do normal, it's obviously not supporting that area at all because it no longer can, but it won't use 31 grams. It's going to save a gram. Yippee, that's like a tenth of a penny. So yeah, support will be worth it in that case, but that's just my opinion. So yeah, I said a lot of stuff. I'm going to start from the beginning and show you again what to do when you first get in the app because you won't have to pay attention to most of that stuff. So if I want to put my part in that my team made, that's an STL file, let's go into the little folder, navigate to where the part is, double click it or click it and open. I'll bring down my settings here and I'll pick a preset. Maybe I want this quality right here to have a layer, height of 0.16. And I'm going to pay attention to the orientation of the part. I'll talk about that in a sec as well. But this thing, I want it to have support. So I'm going to go down and remember to click the enable support feature and do tree. And I'll set my angle. I don't really know why I did 51. That's really weird. I'll set my angle there. Slice it, which converts it into G code. And now when I preview it, I can see what the supports will look like and everything. Really cool. When I hit save to disk, it's going to export a G code file to somewhere such as the SD card you then put in the printer. When I put it on that SD card, I can eject it. Boom, done. Presets are convenient in that sense. So in that case, if I'm printing this bracket, that would work. It's cool. That's how to use it. I wanted to also spend 5 minutes, hopefully before we bounce over to the lab, in case y'all want to see how to set up the printer on the device side of things, to talk about the orientation of your print, because this orientation is going to produce a significantly different output than this orientation right here. Essentially, the part is most likely to fail parallel to the print area with a force loaded to it. So I have literally no idea how to break out this projector screen. Perfect. That's another one of my with a marker.
I got a mark.
Or that, that's correct, yes.
Hopefully it doesn't.
Very much makes the one one shot.
How we feel on thus far? It's a lot, isn't it? But just use the presets, I promise you again. So if I have that part, it looks like this. And I can print it with my bed right here. And it's gonna print it in layers like this. And remember, those pinholes are gonna be right here, right here. So I'm gonna ideally, screw it into the wall right there. And I will screw it into the wall right here. So in other words, there's a force from the screw going that way, and a force from the screw going that way. And most likely, the part is going to be loaded in some manner, in this, maybe the part is sitting on, from a shelf like this, and it's going to push with some big, let me draw this the other way. I have a wall like this, and I have that angled bracket thing right here. It's a big old plate. The plate is going to put a force going down. My layer lines look like this, right? When you put a load parallel to the layer line, it will shear significantly faster than if you printed the part deep to the printer. So this is your bed, and it looks like that. I'll show what that looks like over here. But essentially, your layer lines will now run flat parallel to the bed always, because it's drawing it by layer and then goes up and draws it by layer. So my layer lines, as we can see, look like this. It's significantly harder to break the part perpendicular to the layer lines. So if I had this drawing it from a front view now, so this is my wall. And I have my little bracket right here. I don't really know how to draw this. And I have my big old shelf right here. The layer lines running away. What would it be? Like into it like this? It's gonna be a lot harder for it to snap it. The part will fail by shear force parallel to layer lines. So in this case, let me zoom out and try to make this make sense. You would be trying to crush the part now in this direction. It's most likely would sort of crack open the layer lines as opposed to just flat out shear it off if you do it this way. A lot harder to break it in this orientation. So the piece I want to point out is the obvious way to print this is flat and like at an angle because it looks convenient, but it is it's exponentially stronger printing out like this. Now, if you made a strength to infill plot with these two parts, the way I oriented them the first time in this, as you increase the infill, they'll eventually have a very similar strength because it's becoming solid. But it will shear that hollow shape along the layer lines a lot easier if it's printed the other way than this. But solid is solid. So as you make it less hollow, it will be stronger. Don't know if that makes sense, but I saw this online. I thought it was a quick, easy demo. Yeah, you'd be trying to crush it as opposed to like shear it. I don't know if that makes sense. So again, if I stick my part in, make sure to pick your preset, have the right printer selected because there are two. Pick the right preset and check off your supports. What questions do we have? What can I help with while we're here? Tight. Okay.